Ever. All right, welcome everybody to Cassandra Lunch 17. If you are interested in the previous and future Cassandra Lunch recordings, they're all on YouTube. You should be able to just go to YouTube and look for Cassandra Lunch, because I doubt that there's anybody else doing this. We are a group that discusses Cassandra. It's actually an offshoot of Cassandra DC and Chicago. Today we're going to be talking about tombstones, not the tombstone pizzas and not the tombstones in a graveyard, but tombstones in Cassandra. Here are the co-organizers. We're always looking for people to help. Feel free to reach out to us. Our email addresses are here. We are part of a larger community of meetups. We're committed to diversity and always looking for people to speak on, well, in this case, Cassandra or related technologies. As I mentioned, we're part of a much bigger community of meetups related to data in the DC area, also known as DC2. And we are a nonprofit. And as I mentioned, we cover here Cassandra, variants of Cassandra like DataStax, Cassandra, Cosmos, managed key spaces. I think it's called Managed Key Space Service at Amazon. Normally at this time, we'd ask somebody who has not been here before to introduce themselves, but I think we're good. Group rules. If you have a question, just ask it. You can ask it in the chat, and if I don't respond to it or the speaker doesn't respond to it, maybe you can just quickly just mention it. DataStax is a partner and sponsor, so is GW. And here are some of our local sponsors in DC and Chicago. Organizationally, these organizations have sponsored us at the nonprofit level, and it used to be that they gave us more than just venue space and pizza money, and that's still the case. That to run all the different meetups, to make up for the shortfalls of each group. The donations from these companies, they help us sustain the group. Any announcements for anybody on, let's say, events? I don't think we have any events coming up. There are always events on DataStax, as well as this weekly lunch call. Do we have any events coming up in the next couple of weeks? I didn't see them on our event site.
Not finalized at this time, not yet.
Got it. Yeah, we're just closing up. Well, we closed up August, and we're just starting September, so keep you posted. All right. So, as I mentioned, today we're going to talk about tombstones. Tombstones are one of the biggest areas of pain that people have in Cassandra. It's because they don't understand why they're necessary. So, what we're going to talk today about is why do we need tombstones? And in that we're going to cover what are they exactly, right? Like we talk about tombstones, essentially what are they at the computer level? What are they? And we'll also talk about how they're created, different ways that they can be created, how do we clean them, and then how do we manage tombstones for the long term. So before I begin, who wants to describe what a tombstone is in Cassandra? Does anybody want to volunteer? Okay. I'm hoping somebody would be able to kind of give a quick understanding. So you know, as most people who are starting out with Cassandra, it is not something that's common knowledge. Like, what is, sorry, my browser has just become fairly unresponsive, and I don't know why. Here we go. I'm going to close up some of these. So, you know, we'll just ask Google, what is a Cassandra tombstone? And see what it has to tell us. Oh, wow, my internet is slow. So, in Cassandra, deleted data is not immediately purged from disk. Instead, Cassandra writes a special value known as a tombstone to indicate that data has been deleted. Tombstones prevent deleted data from being returned during reads, and it will eventually allow the data to be dropped via compaction. So, you know, just to kind of like explain, like the previous knowledge you need to know what a tombstone is how does data get written to Cassandra, right? What's the read and write path? So, let's see, Cassandra. And I want to show it visually so that, you know, we can understand what's happening here. So as we know, Cassandra is a technology that essentially allows for high-speed writes and high-speed reads, not just from one computer, but potentially thousands of computers, right? And the way that it allows us to get that speed is on any given computer, right? Data comes in, and if it belongs there, it gets put into the mem table immediately. That's the live version of the data. And because it's in the mem table, we can quickly request it back. At the same time, it goes to the commit log. And upon a flush, the commit log is cleaned out and an SS table is created. What I mean by SS table is a sorted string table. It's uncompressed. It kind of looks like JSON essentially, but it's key value store internally. And over time, these different SS tables, they get compacted into more and more efficient data stores. And there's different compaction strategies. Okay. On the read side, it's a little bit more complicated. And first of all, you know, I'm assuming at this point, you know, the computer, the node in which the data needs to be retrieved, we know because of the partitioner where the data is, so we pick it up. But when we get there, all we know is that the partition belongs there. We don't know if necessarily which file it's on, right, which SS table it's on. And through a process of the Bloom filter, the partition key cache, the partition summary, the partition index, the compression offset, we're able to then find that data and bring it up. Now, before compactions, the partition, if it doesn't already exist in the mem table, right, if it's in the mem table, it'll just get it from the mem table. But if it doesn't exist in the mem table yet, it has to go and assemble this mem table version of the partition so that we can bring it back. And at that point, it's in the mem table space. Okay. So, still, question is, why do we have tombstones? It comes back to the reason we have tombstones is in Cassandra, we don't go, when we have to do an update to data, or we have to insert information into a partition, we don't go and find that partition first to say, I'm going to add a new row. Or we don't go and find that partition first, and then we don't find that row first to say, I'm going to update this value. We just keep writing SS tables. And during the compaction process, it comes and it makes that partition whole. So I look at a partition like a folder and a piece of paper is basically a row in that partition. But to be able to do this at high speed, okay, I'm not going to go find that filing folder, find that file in that filing cabinet, and then put that row in. What I do is I have like an inbox, and I just keep opening new folders, and I just keep putting, you know, pages into that filing cabinet. But eventually, I go and I reorganize everything, and I put it into the right place. Okay. So if that's how I handle new data, how do I handle deleting data? Well, I do that in the same way. We don't go, let's say I need to remove a piece of paper from the file. So in Cassandra words, we need to go remove a row, or we need to delete a column in a partition. We don't go and find it first and then say, oh, take out this sheet of paper, just go and throw it away. We actually just put a tombstone. We say this data is deleted. So we're appending a marker into the record to say we want this data to be deleted. So then the next time when we do a read, and at this, by the way, when we do that tombstone, the mem table is consistent, right? We delete it from the mem table, but then we also put a marker to say, hey, we're going to delete this. When we do a read, if it's not in the mem table, it reconciles all of the different parts of the partition, including the tombstone, so that if there's some data from an earlier time frame, because the tombstone is later, by the time it gets to the mem table, that mem table does not have that value anymore. So that's kind of the 1,000-foot explanation for why do we need tombstones. We need tombstones for the same reason we have SS tables. We need it to be able to do high-speed writes and high-speed reads from potentially thousands of computers. Okay, so I'm going to pause for a second. Questions about what a tombstone is, so that we don't go into the next step. Okay, here's the question. How is a tombstone different from any other write? So there are different types of tombstones. There can be a partition tombstone. There can be a row tombstone. There can be a cell tombstone. So when it's a write, you generally are saying, here's my partition, here's my row, and here are all the different columns and all the values, right? So when you see it, it doesn't actually look that different, but it's stored in a different part of the metadata. You'll see all the data values, and then you'll see essentially what the tombstone records are. But it's syntactically different. It's still part of a write, but it's a syntactically different set of data. Does that explain your question? I'll show you an example of it in a second. Okay, cool. All right, so we understand what a tombstone is. A tombstone is a way for Cassandra to keep track of data that's deleted, but not have to delete it right then and there in order to be able to be a high-speed system. Okay, so great, we know what a tombstone is. Let's go ahead and we explained what it is, right? We need tombstones to keep track of deletes so that Cassandra can be a high-speed system, right? So that it can scale from one machine to thousands of machines, keeping track of 1 GB to, you know, multiple hundred or 1,000 terabytes. Right? That's kind of the trade-off we get when we have things like Cassandra, is that it's not an immediate delete, but we're able to do these things at scale. So what is a tombstone? So let's take a look at what right. So when we take a look at Tombstone, what is it represented as, right? So See if I can zoom into this a little bit. Right, so in the SS table, we have some partitions, and then we say a tombstone. So sometimes a subsequent tombstone takes precedence, and then you essentially have an SS table to say, here's a tombstone for partition 3, right? Over time, this process of compaction will basically get rid of the tombstones altogether, so they just don't exist there. So that's really what it looks like. I think that's a bad representation. Let me see if there's a better picture. Still not great. Here we go. So here's another example where, you know, we have some data. We said we delete this. The marker just says we want to delete this whole row. After compaction, it goes away. So what does that look like? What does that tombstone look like in the data? And I wanted to see if it had, here's another visual explanation, right? We have a bunch of different SS tables. We merge things in the compaction process. We evict the tombstones, we remove the deletions, and at the end of the compaction process, we get a clean SS table. All right, so enough pictures. Let's take a look at some of the here we go. We'll talk about how do we get tombstones without deleting anything, right? So how do we know when we have tombstones? When we do a trace and you do a read, you'll see how the data came. So it's like we're going to parse this query, we're going to prepare the statement, we're going to go to this, we're going to get the SS table, we're going to merge the tombstones, right? This is before compaction, right? It still has to merge tombstones. We found one SS table, we seek that partition, right? And then we come back, and now we have basically one live table and then 0 tombstone in that particular request. See if we have an example here. Nope. These are all kind of like lightweight examples. Okay, here we go. So let's say we delete data, right? One way to create a tombstone is by putting a null. All right, so what happens when we delete data or we put nulls in Cassandra, inside the SS table, it kind of looks like this. It's compressed format, but here's the partition, right? Here's the key. We have different rows here, right? So this is essentially one row, right? And so where the value is null, it actually puts a different type of cell that says, this is now deleted, right? This is the deletion info. And this is what I was explaining earlier, Ryan, is that it basically is like a write, but there's some special information that makes it different. Okay, so that when this partition is read, we don't actually return this column at all. It does, for all intents and purposes, this no longer exists. It exists on disk, it exists only on disk, but once it comes to the mem table, there are no more tombstones. This is different from when we just write it without the null, right? Then we don't have any even reference to that username row, okay? And that's where tombstones really differ from regular writes is, if you don't have to set the data, don't set the data. Because when you put a null, it will create a tombstone, okay? Another way that tombstones are created is that when you have a frozen collection, it has to essentially update the old collection and then, it has to say delete this old collection and update it with this one. That's another way to kind of create tombstones. Materialized views, I think, is a more advanced topic for tombstones, but let me see if I can give you another example of what these tombstones look like. I could hide this floating meeting control thing. Okay, there we go. Okay. We looked at this already. Okay. This is about dealing with improving performance. I think that's basically it. So I'll come back to this example because I wanted everybody to understand, what a tombstone looks like in the SS table. So now you guys understand like what it looks like. Question is, why is it bad? Why is it bad to delete data in Cassandra instead of just saying don't put the data there at all instead of putting a null value, right? Why is it bad? Because if you have too many tombstones, every time you do a read, it has to reconcile that tombstone, right? It has to pick it up. It then has to remember that, oh, by the way, this data is deleted, so don't send it back. So you essentially have a bunch of data sitting around that is useless to the end user. Another issue that makes tombstones bad is if you have a partition with many, many, many rows, and you have deletes in the form of null values, or you have deletes, every time you pick up that partition, remember, in Cassandra, it's not just picking up the row. It doesn't matter if you say where partition key is equal to this, and column, clustering column is equal to this, and clustering column 2 is equal to this. It doesn't matter. It still is going to get all the parts of the partition. It will reconcile all the tombstones before bringing it up to the mem table level in which it does the filter, right? So that's the big issue, is that when we have tombstones, this is a simple example. This is just one row. Imagine a partition with 100 rows or 1,000 rows. Even if you had one tombstone, that would be 1,000 tombstones that have to be reconciled. So there's a warning in Cassandra that says, hey, we've reached 1,000 tombstones on this read, for example. Okay, and that's a warning. Again, it's not a big deal if you have tombstones. And my number that I say is like, if you're doing 100 or 200 tombstones in a query, you're fine. But if you have billions of queries and you're doing 200 tombstones every single read, that's gonna take up resources. So I don't know about you, but wherever I've worked with Cassandra, people are trying to squeeze the last kilobyte or even a byte out of the memory or the disk, or to maximize the hardware in such a way that it really truly scales. So instead of adding hardware, right, to make performance better, if you can just not do tombstones as much, you could really just scale without adding hardware, right? You're just going to be lowering the load tremendously. So tombstones are good because they delete data. Tombstones are good because they allow us to do distributed deletes, essentially, across one node or 1,000 nodes. They keep us consistent. But tombstones are bad if we have too many of them. And common problem with tombstones is that people will write prepared statements, and they'll bind an object to the prepared statement, right? And if that object has a null value, then the prepared statement will end up executing something like this, and they'll put a null there. And they won't know the difference until the cluster gets bigger, there's more and more requests. They won't know the difference because they just took an application from the relational world and they ported it to the non-relational world. They don't know any better, but it starts to come up. So, looking at back at our agenda, like, how do we create tombstones? So you can basically delete data, right? So that could be a partition. could be a row, could be a cell. You could also insert / update nulls, right? So a row full of nulls, probably no reason to do that, but row with data plus some null values. That's how we create tombstones. Right. So the question is, like, how do we clean these tombstones? If they're good in some ways and really bad in other ways, how do we clean these tombstones? So a couple of ways, right? One is compaction. This is automatic. If you get a bunch of data, depending on how you configured it, Cassandra is going to try to compact it, right? And in compaction, there's some factors. So there's compaction executors, compaction throughput that you can set at the Cassandra level. Okay. But the other place that you can change how quickly tombstones are cleaned are at the table level. We have something called GC grace seconds. Okay, we'll come back to that. And the other is something called a tombstone. It's tombstone compaction threshold. All right, I'll come back to that. I may be wrong about this. So what are these things? Let's say you have a billion rows, okay? And you do a delete on every one of those billion rows. And maybe you've done the design well and you really just have a billion partitions, which is fine. You could have quintillion partitions if you want. But you go to your disk and you're like, I don't see any difference. In fact, I just did a bunch of deletes, but my disk is still full. In fact, it has more used because I deleted this. Well, obviously, because instead of actually deleting it, it has gone and put a tombstone. It has written data, right? So if you really wanted to set it quickly, you could go to that table and set that GC gray seconds to 0. And what that would do is it would prompt the compaction process for that table to, as quickly as possible, start cleaning out tombstones. Okay? You have to watch out, though. If you set it to 0, and there are very, very large partitions, or you have so much information with so many deletes, this could start impacting performance because it's just going to start compacting and compacting and compacting away these tombstones. Well, guess what? Compaction also has to work for legitimate rights. You know, data that's coming in for use, it has to be working for that as well, right? So GC gray seconds usually is like 36, okay, which is roughly 10 days. Okay, that's the default. All right. So if it's 10 days and you want to get rid of it in a day, right? So maybe you set it to 1 day, right? That's an okay time frame. You're not going to impact it as much. If it's really hurting performance because you have a crappy data model, then you probably want to say, let's do 1 hour. Okay. Another reason, the only reason I would say you do 0 is you're just doing development and testing and you just want to delete data, right? Just set it to 0. Okay. That's kind of the only reason. If you want to delete a whole table, just run truncate. Right? Truncate doesn't do tombstones. It just literally deletes the SS tables. It just gets rid of it. The GC gray seconds is one way, and the tombstone threshold is percentage based. And I think one of the articles I'm going to reference here actually has an example of that. Let's see where to go. Let's see. Yeah, it just talks about tombstones. We'll come back to it. Let me see if I can find the exact thing. It's a sub-property. I'm going to put this link in here. By the way, all of the materials we reference in the Cassandra Lunches, they end up getting put on a blog post on our blog. So feel free to go to blog.anant.us and subscribe to the mailing list to get updates on this. So in compaction, sorry, this is a little old. We'll do Cassandra. Well, it's still relevant, even though this is Cassandra 2.1. tombstone compaction interval. And then there's also a tombstone threshold. So actually, there's 3 items. So I'm going to write this down if my mouse will help. Oh, okay, tombstone threshold. Oh, sorry guys, my computer is just being a little annoying. Another one is tombstone compaction interval. And it's like unchecked tombstone compaction. All right, so, oops. All right, so tombstone compaction interval, the minimum number of seconds after an SS table is created before Cassandra considers the SS table for tombstone compaction. Right? Cassandra performs tombstone compaction on SS table if the table exceeds the tombstone threshold ratio, right? So it may check it every day or it may check it every hour, but if it's not meeting this threshold, it won't do a tombstone compaction. Okay, so when we set it to 0, it does something, which is it forces a cleanup, but we still need to consider, well, what is the interval that we want to check it, right? So maybe we want to set this to, it's already set to 1 day, right? So maybe we want to set it to 1 hour. For the percentage, if it's 20% or 0.2, maybe we want to set it to, I don't know, 0.05 or 5%. So we could reduce this to 1 day, for example. And finally, unchecked tombstone compaction means that it will run a tombstone compaction without pre-checking if the tables are actually eligible for, tombstone compaction. It doesn't even care about this. So when you set this to true, it doesn't care about this at all. Right? It doesn't care about, sorry, it cares about this, it just doesn't care about this threshold. Right? So when we have tombstones, we can manage them by setting these properties, but you can also force a cleanup, right? And there's a couple of ways that I have learned. One is node tool compaction, right? Compact. I'll get some parameters in a second. There's also node tool garbage collect. And there's also something called node tool scrub. All of these are heavy operations. Okay. And if you don't give it a key space and if you don't give it a table, it will run on all the key space and it'll run on all the tables and it's not good, no bueno, right? Let's talk about what these are. Node tool compact is following the compaction strategy, and given some parameters, it can do a major compaction or it'll just do the next step. Garbage collect does more than that. It is actually going through and it is it's not a Java garbage collection, right? This is a Cassandra garbage collection. It is going and it is pruning duplicates. It's pruning tombstones, and then finally, node tool scrub. It's going through the SS tables, and its pure job is to scrub for tombstones. And it's actually kind of like rewriting the SS table. And all of these work. Would I recommend it that you do it in production? No, I wouldn't recommend it at all. I would rather have you not write tombstones or set proper settings so that it can be managed properly than to have to resort to essentially manual intervention. These are manual commands that you'd be doing. You don't want to do that. Okay. One of the articles that I'm going to refer to here. So here you go. Right. We can lower the GC gray seconds, which we talked about. We can then garbage collect. It triggers the compaction process. Right. That's one way to do that. Compaction if it has a lower GC gray seconds, will work fine, but garbage collect specifically focuses on the Tombstone compaction. And not many people talk about GC gray, not many people talk about compaction, but let me see if I can find any reference to it. What does no tool scrub do? Yep. So no tool scrub, as I mentioned, it kind of like rebuilds the SS table. But when it rebuilds the SS table, it is going and it's cleaning out tombstones, right? It's a heavy operation. There was one case in which I was working for a client where the system was an e-commerce system, and basically they had an import process which at night was creating tombstones because it was using prepared statements and it was creating these nulls, and it would create thousands of tombstones. And because of the bad data model design, it was hitting only a few partitions, right? And essentially, because we couldn't put in a data model change quickly because of the dev cycles were so slow, what we had to do was we had to put in place GC gray seconds, tombstone threshold, tombstone compaction interval, so that during the day it would be okay. But then at night, right after the import, we would push a no tool scrub command, and then we would push a no tool garbage collect command. It was like on a cron job on every machine, but at a different time. And it was like the most hacky version of resolving tombstones. But unfortunately, that's what we have to do, right? And this is why, I mean, you don't see a lot of people that talk about no tool scrub because it is just not something you do, something you use on a regular basis to basically fix SS tables, right? It's rewriting it. That's why it's going to be a better version of it. Okay. So we talk about, how do we create it? Nulls, deleting data creates tombstones. We talked about why it's important. We need tombstones to keep track of delete, so Cassandra can, be a high-speed system, right? So they can scale from one machine to thousands of machines, keep track of 1 gigabyte to petabytes of data, and it can do it fast. That's why we need Tombstone. We talked about how to clean it, changing things, changing some settings, if we can't help create them, and we can manage them with certain tools. The million-dollar question is, how do you know that you have tombstones, right? How do you know? Well, we noticed in one of the articles that people can essentially use SS table dump, right? How likely is that you're going to go and in the middle of an operating platform start doing SS table dump to see what tombstones are being created? Like, you're probably not going to do that, right? The way that you can watch out for them is dependent on your system. Okay, you may have your Cassandra YAML configured with certain thresholds. Okay, meaning give me, if it's over 1,000, right? Just let me know, right? So there are settings inside Cassandra.YAML, and what it will do is in the system.log, it will say, warning, right? Warning, I'm going past a certain amount of tombstones. So that's one way to do it. The other way to just watch is using SS table stats. So in in NoTool, there's a table stats. So there's something called table stats, and if you're using an older version of Cassandra, like 2 and before, you're going to have something called TF stats. CF stats, excuse me, not TF stats. And the stats will show you the number of keys, right? It will show you the number of, how much space on that one particular machine you have tombstones. And table stats are all individual for each node. So when you run a table stats command on one computer, you're just getting it for that one computer. You're not getting it for all of the computers, right? You're just getting it for one computer. So if you don't have something like Op Center, and especially in the newer version of DataStax, it tracks tombstones. The only way to see tombstones across the cluster is for you to go and run table stats on each machine and see what the output shows. So it will show average tombstones per slice. Per slice meaning every time you do a query, what's the average number of tombstones? Maximum tombstones per slice, right? How bad is it? Okay, and it gives you a bunch of other stuff, right? Compacted, partition minimum. This is telling you how big the partitions are, essentially. This is a good health check. We can talk about that later in a data modeling session. But this is how you know you have tombstones. If you say NoTool table stats without the key space, and you just grep for maximum tombstones, you'll get how many tombstones you have across all the tables. So this is a quick, yeah, here's an output, right? This is what it looks like, right? Now, if you don't have Op Center, right, and there are other options, you can use Prometheus and Grafana. So if you look at Cassandra Toolkit, Cassandra Toolkits is a set of tools that our team has put together, assembled it. Part of it is assembled, and part of it we have created. And when we say assembled, we didn't make these tools. We didn't make Prometheus. We didn't make Grafana. We didn't make Elasticsearch or Kibana. But what we did was we put it in a Docker container, so in a Docker Compose, so that you can quickly just bring up the toolkit and check it out. But there are two things in here that may be useful that you can't find anywhere else. One of them is called Table Analyzer. Table Analyzer is and I recommend you look at the dev branch, because there's a lot more work in the dev branch than there's the master branch right now. Table Analyzer takes the CF stats from, let's say you have a cluster of 10 computers. It can use SSH, or it can use NoTool to remotely get the data from each machine. And it will transform that CF stats output into CSVs, and then eventually it creates an Excel file view with conditional formatting. So you could quickly see how bad the tombstones are. And you're not just checking to see what the tombstones are across each machine. What this tool will do is it'll allow you to see how the tombstone counts are different between nodes. Okay, as a distributed system, you want the same load, reads, writes, storage, compacted, minimum, maximum, average bytes. We want what CF stats has to give us, what table stats has to give us. We want that same general data for every table across every computer, because then we have truly distributed the work of the system. If we see that 3 out of 9 computers have higher tombstone in the average tombstones or the live tombstones, then that means there are some hot partitions, meaning we're doing a lot more operations on those partitions. And we want to check, why do these partitions have higher amount of deletes than everything else? Okay. So anyways, Table Analyzer, that'll get you part of the way there, right? It'll give you a snapshot in time. The other tool you can use is called, we're not calling it anything it's a log analysis process, but using the node analyzer, what we do is we collect the logs from all of the machines in the cluster, system log, GC log, even some system like Linux logs. We tar them up, and using the log analysis tool, we can ingest them into a offline ELK instance. When I say offline, it means that it's not really actively ingesting from the cluster. We just take the last whatever days of logs that we have, and we tar it up and we ingest it. And that ingestion allows us to see in ELK, we can do a query. We can say, show tombstone warning. Let me just do a search. And you can see on a timeline how many times that tombstone warning came up. Right? That's another way to kind of see if there's any problems with tombstones. All right. Now, you can go into your file beat and dissect the exact keyword for tombstone, and you can even put it, you can parse that number so you could graph over time what your tombstone warning is. Okay. That's one way to do this. But more than likely, if you learn from our mistakes or anybody else that has been working with this stuff for a while, you're better off just connecting ELK with FileBeat on a live cluster. So not trying to find this offline, but rather having the logs get into some sort of visualization all the time. Prometheus and Grafana will get other information. So technically, you can get the tombstone average and minimum and maximum, et cetera, from the Cassandra exporter and get that into Prometheus. You can also graph it there. But this is assuming that you're always collecting information, right? So the benefit of ELK is you can do it online, meaning all the time, or you can do it offline. With the rest of this stuff, you kind of have to have it connected. Ideally, you have all of these tools installed, and you have the agents for these tools installed as well on the cluster, so that you can be monitoring it on an ongoing basis. These are all open source-ish tools. And when I say ish, Elasticsearch and Kibana have a different licensing scheme, but they're all free. There's no excuse not to use it. But it doesn't mean you can't use other tools. Like you can use CloudWatch, you can use Datadog, you can use New Relic. There's an article that we have out. If you look for monitoring Cassandra, here we go. I'll put this in the resources and we get the blog post out as well. My computer is squeaking today. I'm going to try to be patient with it. Oh, it is not doing it. I'll make sure that link is there. But monitoring Cassandra is a thing. There's a whole like cottage industry of companies that give you resources to monitor it properly. So, you know, if you don't want to do the work of bringing up ELK and Prometheus and Grafana, that's completely fine. You know, Datadog has like a per month per node cost. New Relic has got some weird, complicated pricing scheme amongst other technologies out there. Semitex is another one that does it. Yeah, my computer's just literally giving me the middle finger as I do this. So I apologize for that. But there's an important reason why we do this, right? We want to make sure that the load on any given machine for Tombstones or for any other matter is distributed across every computer. And not everybody uses DataStax, right? So DataStax has the tools already kind of built in to do, to monitor everything. But for those that don't have DataStax, Grafana is, you know, it's as good as long as you have the data collected all the time, right? And actually, you know what? I don't have my Astra cluster running, but if you use DataStax Astra, they use Grafana and Prometheus to monitor and to show the dashboard. It's like embedded into the Astra interface. So you're not really, gonna lose out by using Grafana versus Op Center. Op Center is for data stacks, but Grafana and Prometheus is the pro tool to use for Cassandra. To wrap it up, just gonna reiterate what we talked about today. So we need tombstones in Cassandra because we want to track deletes at a high speed, right? We're not going and finding the partition or the row and then deleting data. We're just saying, I need to delete this. We'll delete it later. And every time I do a read, I know that I put that marker in there, so it reconciles it. It allows us to scale because the deletes are distributed, right? That's why we need it. I didn't fill this out, but I'll fill it out. Okay. What is it exactly? It is a type of write with deletion info, not deleton, info, as to when to delete it, okay? What we didn't talk about, actually, I forgot. I don't have any reason for why I didn't talk about it. But the other way that tombstones are created is if we have something called a time to live value, okay? And we can put a time to live at the table level, at the row level, or even the cell level. A TTL just says, delete this data after a certain time. So we can put a TTL of like 60 days. That means every time I update data, every time I write data, it adds a deleted info for the future, okay? Now, in this case, because it's in the future, it's not as bad. It still creates a tombstone, but that because the deletion is happening in the future, it doesn't impact the read as much, right? It's there, but it doesn't have to like do all this mumbo jumbo. So that's another way to create TTLs. Create tombstones. In terms of cleanup, we can tune Cassandra to tune it up in a way that it does more compactions, etc. We can tune the table to delete data more quickly. We can tune the tombstone threshold and compaction interval, or we can get rid of the checking of tombstone compaction threshold altogether to do this more frequently, and to do it on a generally more quicker basis. And then finally, to manage tombstones, we have some no tool commands to force the evictions. And then finally, to monitor tombstones, we have things like no tool table stats, right? Which you can use in, just on the command line to get a quick view. You can do log analysis, right? You look for warnings. And some of the tools you can use for no tool table stats beyond just looking at the file is look for Cassandra Toolkit Table Analyzer, right? In conjunction with, for log analysis, again, Cassandra Toolkit, look for Node Analyzer, which will help you gather the logs. And now that I think about it, we should probably just merge log analysis with Node Analyzer. All right, so that's the end of my tirade about tombstones. Any questions about any of the things we talked about today? So what are tombstones? Why are they? How are they created? How do we clean them? How do we manage them? How do we monitor them? Nope. All right. Well, with that, we can wrap it up and give you guys back 4 minutes of your day. Next week, same time, same place, we will have the next one. Let's see what we're going to talk about next week. Use cases, combined use of relational and Cassandra. This was a request a while ago. so we can talk about that next week. And yeah, go ahead. There's a question.
Raul, I was just going to ask, where can I get a hold of the PowerPoints you use and the materials?
Sure. So I didn't really use any PowerPoint today. This is just the same kind of like Meetup PowerPoint that I just talk about, our Meetup group. But the outlines that are here, they get put into the blog posts. So the videos will go onto YouTube. If there is a slide deck that one of our team members creates out of this as part of the blog, that'll go into SlideShare. But the best place to find out about the slides, the videos, and this general explanation is just to go to our blog, which is blog.anant.us, and just subscribe to the newsletter, and you'll get a notification every time. I think the newsletter goes out every month, but I think that's changing. We're going to have notifications going out more frequently. Okay.
Cool. Got it. Thanks, man.
Yep. Awesome. All right, folks. Thank you very much for joining us for the 17th installment of Cassandra Lunch. Looking forward to next week. And you guys have a wonderful day. Thank you.
You too, man.
Thank you.